Welcome to Khetz Tutorials, and in this video I'll be talking about Numpy arrays. And I should just say that I'm super excited to be presenting this lesson because I absolutely love these. So let's get right into it. Numpy arrays, right? So that is what we'll be talking about. So let's create a file called Numpy arrays or arrays. I'm not quite sure what we can call this. I just called it Numpy arrays, written in camel case. So let's have that as big A. Okay, you can call it, go ahead and call it anything you want. So let's break the name down. Numpy, let's start with Numpy. If you remember in the previous video where we talked about modules, I'll just link it on the top right. I mentioned that some modules or libraries are built in and you can just import those, but Numpy is one of those. So Numpy is a library and it's one of those that are not built in, so you have to install. Before we even talk about Numpy, it comes to your terminal, either this one that's in VS Code or your CMD, which is your command prompt, which comes with your computer, and you type pip install. If you follow the installation instructions which I gave at the start of the series, then this should work for you. You should just say pip install numpy, right? And then just press enter. From this point, then it will basically install numpy for you. Now, after installing numpy, you then say import numpy. But now Numpy is too long, so we want to shorten it a bit. In the same video where I talked about modules, I talked about this. You can give another name to a module or library. So I want to call Numpy NP, but what is Numpy? So Numpy in full is numerical or numeric Python. And there are a lot of functions, there are a lot of things that you can use inside Numpy. It's very, very powerful. It's usually used in engineering and some other scientific calculations, basically for experimental data and processing that data. I can give you an example. I used it personally in my computer engineering degree in a course called AI, where we were doing neural networks, as well as another one called digital communications, where we're basically doing a bunch of cool stuff. So these are quite useful, and you don't have to do a lot of complex things to find some use or to find a reason to use these. So let's get right into what they actually are, how you use Numpy arrays and stuff like that. So, okay, we've covered the Numpy part of it. Let's cover the array part of it. So if you remember, we talked about lists and tuples. So arrays are quite similar to those. The main difference being that we're now dealing with the same type of data. So an array carries the same type of data and it has a similar storage structure to lists that are in Python. So just know that you have to keep the same type of data in the array. And in this case, we're saying Numpy array. And in this case, we're talking about Numpy arrays. So numeric, Python, and then arrays. So that should tell you that we're actually dealing with numbers. So Numpy arrays store numbers in different forms. They can be, let's write this in terms of comments if you want to use that. They can be floats, they can be ints, and they can be complex numbers and some other formats which are more specific, but these are the basic or the general ones that you can play around with. So now we are basically talking about lists, but which are a bit different from lists if you want to look at it like that. So let's actually look at Numpy arrays and how you define a Numpy array. These can come in 1D, 2D, and 3D, but we'll only talk about 1D and 2D arrays. And if you're wondering what those are or what that exactly means, we'll get right into that in a moment. Okay, so 0 is a good starting point. Let me show you something which is quite cool. We can actually define a Numpy array that only has zeros. So how would you do that? So let's print the array that we're actually creating. So you'd say NP, which is what we defined our Numpy library as, and you'd say dot 0 with an S, so zeros. Now in here, you'd have a tuple or you just have these round braces again in here. And the round braces without the 9 would contain the shape of your array. And by the shape of the array, this is what I'm referring to. So now look at NumPy arrays as these kind of boxes or matrices. So you have rows which go like that. So in this direction, you have rows. If I had elements over here, 1, 2, 3, I'd have 1, 2, 3 rows. So if I go this way, this is one row, that is another row, that is another row. And now if I go in this direction, I now have columns. So 1, 2, 3 as well. So what goes in these brackets is the shape. So if I define a 3 by 3 matrix or an array, it would look like this. I'd have 3 elements going down. I'd have 3 elements across. So this one would be the row, and this one would be the column. So that is how you define most of these NumPy arrays. You're going to specify the shape or the dimensions that are related. So the dimension is a totally different thing. Let's talk about it as the shape. It's technically called the shape. So now we're going to define the shape. So let's give it one row, and let's say it has 5 columns. So here's what we expect. We expect our array to have one row, so only one element if you look at it from the side, but we expect 1, 2, up to 5. So this is what we expect. And we've now said that this is a NumPy array that has been filled with zeros. So if I print this NumPy array, and you can assign this to a variable name, you can call it 0 array, 0 underscore array, and say equal. I'm just going to paste that. And in here, you can just do that. I just wanted to directly have it inside the print statement, so you can do it in either way. So this is how you generally define a NumPy array that only has zeros. Let's say np.zeros. Then you put in the shape of that NumPy array. So let's see the result. Let's see what we have. So let's wait, and it's loading, taking quite some time, but we are patient people. So let's look at what we have. So that is the result. And as we expected, this is what we have. So this is the general format of NumPy arrays. The output will be a float, and you have the option of actually specifying how you'd want your NumPy arrays to be displayed. So you also have an option. If I put a comma after the shape, you'd see that it actually gives me the option to specify the D type. And now what the D type is the data type. So you have a lot of data types that are associated with NumPy arrays. I can say D type equals, and you should now input your data type. It can be an int, and as you can see, there are a lot of these things that you can actually put in there. Let's try int. Now, if I try int, clear the terminal and run that again, then you'd see that the decimal points are now gone because we've now specified that we want this to be formatted as a int, which does not have a decimal point. But at the end of the day, the most important thing is that we have this shape, which is one row and 5 columns. So one row and 1, 2, 3, 4, 5 columns. So that is the basic principle that governs how you define arrays. And cool enough, we also have another one which is called ones. Okay, so you just replace zeros with ones, and this basically just have ones everywhere instead of zeros. So you use the same principle. We can also change that. So one's array or one array. I'm not quite sure what you want to call it. It's totally up to you. It's a variable name, so you can give it any name. So now that is what we have. And if you look at this just as ones instead of zeros, and once again, you can also specify the data type. You can specify this to be complex. If you're familiar with complex numbers, this can also be complex. And if you print that, it should also have an imaginary part. And that is what we have over there. If you aren't familiar with complex numbers, don't worry about this, but just know they're complex numbers in the world. And that is what we have. So this is an optional thing that you can put, which is the D type, the data type. And we talked about data types in our variables video. We have quite a few data types, but the main ones that are associated with NumPy arrays are the ints, floats, and complex numbers. So you now know how to create a NumPy array that only has zeros, a NumPy array that only has ones, right? So we've only talked about one that has one row. But what if we want to have the same number of rows? Remember when I was drawing the matrix, or when I was drawing the first one, and I illustrated the rows, I talked about a 3 by 3. So let's look at how this looks. And that to me is quite cool. We have 1, 2, 3 rows and 3 columns, and that looks like a matrix, right? So in technical terms, it's not a matrix because NumPy also has another function called a matrix, but you can use this as a matrix, and that is a cool thing about it. So if you're doing linear algebra, if you're doing anything that requires matrix operations, this is very useful, and you're going to use NumPy arrays a lot. And one other thing that I actually didn't think about adding in the video, but I just want to add just for the sake of adding it because it's a cool feature. What you can do is you can multiply all of the ones that are inside this array with a value, and that would mean that every point in the array has this value. So if you multiply 1 by anything, then that anything becomes the new number. So if I multiply all of these by 100, what do you expect? Let's see what actually happens. So I'm going to multiply all of those by 100. And everywhere, instead of the ones, we just have 100. So if you wanted to create a NumPy array which had placeholders, which would be changed at a later stage, this is what you do. You can define a NumPy array that is filled with ones and just multiply. You just do it once and it multiplies everything for you. This is cool, right? So this is how you define NumPy arrays that has zeros or ones, and we looked at one that only has one row, and you can just change these numbers, which are the shape, so that it looks differently, right? So now we're going to look at the general case that you'd use to define a NumPy array. Obviously, it's not always useful that we have the same numbers, either zeros or ones or any other value. You might want to have a bunch of values which are not associated, or values which are basically different. So here's one way that you can define a NumPy array. We talked about lists in a previous video, and now we can use a similar example. Let's say you wanted to store your marks in a NumPy array. We're quite optimistic, so let's go rather for high marks, right? So now let's say those are your marks, and you want, this is a list, by the way. So this is a list, but we now want to store this as a NumPy array. So this is how you do it. So marks underscore array, you can call it that, and say equal. So you'd start by saying np.array. And this basically converts the list into a NumPy array. So you're going to put marks in there. You could have also had this literally in there. So you could have just had that in there without even defining the mark thing. But let's just do it like this. And now if I print, I'm going to print marks underscore array. And let's see the result. And it's just basically the same, right? It's basically the same. It doesn't look different, or doesn't look like anything really happened, but it's now a NumPy array. And what you can do with this is you can do a bunch of interesting things, and we're going to look at those interesting things that I'm referring to. And this is one way that you can define it, and I'll also show that you can have the list literally inside that NumPy array. Now let's say you wanted to define an array that had more than one row. So this just had one row, so it's not really different from defining lists. And here's how you can define your own. So let's say you had student marks, and each row could be associated with a student, right? And we'd call this an MP array. And let me first write this down before we discuss it. So let's say student 1 as T1. We have their marks over here. Let's say 60, 70, 90. So these marks are associated with that student. and so on. These marks associated with that student. So this is what we want to do, or this is just an example which we want to use. But the question is, how would you define the actual array? How does it look like when you're defining this from scratch? So what you do is you'd have the curly braces. These are not curly braces, these are round brackets. So you'd have the round brackets around the first np.array. Then inside you'd have these square brackets which carry everything that's going to be defined. And now in here you'd also have some other brackets, and each of these brackets that are now inside here, so these internal ones, now represent the row. And to go to another row, you put a comma, other braces, comma, some other braces. So if I have 3 braces of this type inside, that implies, or that says that I have 3 rows. And now the numbers that I write in here now form the columns. So you could also put it like this so that it looks like the output, right? So if you put it like this, then it's going to be quite similar to the output. If you want to look at it like that, or you can write it in the form that I previously had it in. You're just going to write some random marks so that we actually fill this up. Okay. So this looks like the output that we actually expect, and we're just going to say print student underscore array. So I didn't type this properly. I'm just going to fix that and run the program. Now, if I run the program, it looks quite similar to this, just that I didn't have the comments. So you can write it in this format, or you can change it back to this format, which looks something like that. Doesn't really matter. So whatever works for you, but what you have to understand is you need these round brackets which hold everything. You need the first rectangular bracket that rows the array itself, and each rectangular brace set that you have in here basically defines a row. And if it makes it easier for you to see visually, then you can format it like this so that you see that, oh, this is the first row, the second row, third row, and stuff like that. So there are quite a lot of things that I can actually talk about that are related to these NumPy arrays. You can reshape the array. So if this current array is a 3x3, you can reshape it to any shape that makes sense, or any shape that is a multiple of the total number of elements that are inside this array. And now, since there are a lot of things to cover, I'm only going to cover a few and leave the rest for your specific application or whatever that you want to do. I'll just link or just hint some things that you can look up if you are looking for a specific thing, right? So things like operators, like adding to arrays, dividing them or doing, I won't cover that. I also won't cover slicing. I also won't cover reshaping. Those are some things that you can actually look up for yourself. What I do want to cover though is I want to cover how you can actually access the elements inside the NumPy array once you've defined it, right? So let's start with an array, which is a simple one. This just looks like this. I'm going to uncomment that out. Then I'm going to close the brackets over here so that this actually is just that. So now that I've commented this out, if you remember that comments are not read by the interpreter, so it's like that code is not there. I just want to comment it out because we're going to use it again. So now the array only is that portion, and I can just print that to confirm for you. If you look at that, that is just my array over there. So that's fine. So that is the array that we have. And the question is, how would you access the elements? Let's say you wanted to use just one element in the array for whatever reason. How do you actually access the elements? And the answer is it's quite similar to how you do with lists. So let's say you want to pick out, or let's actually try an experiment. What do you expect to get when you put 1 in there? So this is the index operator, just like we use for lists and tuples. And if you look at that, it actually tells you that this is out of bounds. And the question is, why is that? So let's revisit what we've actually done over here. So we have a NumPy array. and it registers. Remember that this one covers everything, and the next one is associated with a row. So this is a row on its own. So this is a 1 by 3 array. So it has 1 row and 3 columns, right? Which means that, remembering that we start at index 0, right? Which means that 1 is actually not valid. And what it's trying to do is it's trying to access the row at the index 1. Now that we've defined that we have rows and columns, you have to specify both of them when you're trying to access a specific element. So where am I looking? If I want to take 70 out, I have to mention that I'm looking at the first row, which is 0, and I'm looking for the element at index 1, which is associated with the column. So when you specify the position of items when dealing with NumPy arrays, if they're actually defined like this, you have to specify the row that the element you're trying to take is in, as well as the column that it finds itself in. So that is why we're getting an error. We're trying to access row 1, which is not a valid index. We only have 1 row, which means the only index available is 0 because the indices start at index 0. And an interesting thing is, if I just say index 0, it will take the whole row, which means it will just give me everything that's inside here and not a specific element that I'm looking for. If I want a specific element, I have to specify where it is in terms of columns. So the first number specifies the row. So this is row 0, the first one. And if I want to access each of these, I have to use the column. The column specifies if I were to look down, where would it be? And remember, this is how we count. So if you were to look down and you wanted to access 80, that would be at index 2. So if I now do that, and this is the format that you do this in, or you can have it in this way. If you want to split it up, you can have 0 in its own brackets, you can have 2 in its own brackets, and if you run that, you actually do get 80. But if you want to have it more compact, you can just break the walls over there and just have it in a comma. So in one set of brackets, and you just have a comma in between those two things, and we can change this to, let's say, 1, so that we can take 70 out, and that is what you have. So this is an important thing. Once you define NumPy array, and when you print it, or in its definition, you specify that you have a specific row. So the ones on the outer side cover the whole array. Those would be the rectangular brackets. But the ones on the inside specify that this is a specific row. Once you have a specific row associated with elements, you have to specify it like this if you want to take out an element from that. So if we even bring this back over here, so we can bring this back, and we can cancel all of that and put a comma instead. What would you, I wish I could ask you which one you'd want us to take out, but let's say we wanted to take 85 out. So where is 85? 85 is on the second row. So first row, second row, but remember how we count. So going down 0, 1, 2, going to this way, then we have that as well. So it's like a grid of some sort. And if you look at this, 85 is at row 1, column 1. So if we say 1, 1, now we expect to get 85 as the output, and that is what we have. And as you saw, if you want to take the whole row out, you just specify the row. So remember that the first number is the row. So if you want to take this row out, which is row 1, according to the indices, but row 2, according to us counting from the top, then it will basically just take the whole thing out, and that is what. And you can use all of that in your core calculations wherever you want to use that. So you can access a whole row when dealing with NumPy arrays, or you can access a whole column. So if you want to access a whole column, it's quite complicated. I don't want to get into it. It's not really complicated, just that you do this funny thing over here. So you do this funny thing and you specify let's say I wanted to take the second column, which would be that one. And the second column in terms of us looking down would be this one. And it's at index 1. And if I run that, then I expect it to be at the output, but yeah, so it's 70, 85, and 98. But now you might be asking, what is this thing over here? So don't worry too much about that. Or you can look it up, just search for this, slicing, right? So just search for this if you're really curious or you want to find out what that exactly means. But this is not part of a lesson. I just wanted to show you that you can access the rows or the columns, right? Let's keep it simple at this stage. If you're really, really curious, just look up slicing. So now we've actually learned what NumPy arrays are. They store numbers, and you can specify the data type of the numbers that you store. You can have NumPy arrays that only have zeros. You can have NumPy arrays that only have ones, or any placeholder that you multiply by. You can now define your own NumPy arrays that have rows and columns. You can define a NumPy array which is one-dimensional, which basically means that it's just like a list. Or you can have some of them which look like this. And there are a bunch of things that you can check, or there are attributes that are related to the NumPy array that you can check. You can check the data type, you can check the number of dimension, you can check something called strides, and it's quite cool to work with. So truthfully speaking, I don't think we can cover everything that is associated with, first of all, NumPy in a single video. If we can, then it'll be a long video. Also, if we even talk about NumPy arrays, I don't think we can cover everything that there is to them in one video. So I'd rather want to stop the video here because I've already covered a lot. And the information that I've shared up until this point is quite useful if you just want to use your NumPy arrays for basic calculations. If you just want to use your NumPy arrays for basic things, that's all I can summarize it to be. And I hope this was useful and you got to understand one of the most fundamental things, which is defining the arrays and accessing whatever it is that you want to take out of those arrays. So you can check for equality of arrays. If you have two NumPy arrays, you can check if they're equal. There's a function for that. You can multiply them. You can do the dot product. You can do, so if you're doing calculus, if you're doing anything that requires you to do matrix operations, these are your go-tos, and they're quite powerful. They're quite useful, and I do really enjoy using them. So I hope you enjoyed this brief introduction into your NumPy arrays, and I hope the information that you got here can be useful to you. I just link in the description the NumPy official site where you can find some other functions. So whenever you need a function, you should know by now that you can actually look it up and see if you can use it and actually see how to use it. So the NumPy website actually has these things, it describes them quite well, and you can just look up some of the things that you might want to do. So instead of doing things manually, you can just go up to the NumPy website and actually see how you can manipulate your NumPy arrays as you wish. So this is the end of the video, and this is all I'm going to talk about. If you like the video, just give it a thumbs up. And if you haven't subscribed, please consider subscribing. I'll see you in the next video.